Hi there. Now I'm going to show a demo of or our apps that's going to change massive MIMO order to MIMO and higher order from 64 T64R to lower. It could be also adjusted for higher order of the antenna elements. Let's say 128 256 and so on and so forth. But as it has been done for a practical experiment, we have considered 64T64R. At the moment we already set let's say or a configuration for the test. We have 3 cells and with different users in each cell with let's say configurations that you can see here, guarantee bit rate, conversational voice. And now we are going to run the test and see the impact of our apps on it. How our apps works, we have divided a day into different 4 time period. Namely, it's from let's say it would be from midnight to 8 morning to 3 p.m., 3 p.m. to 5, and 5 to midnight. And the varies could be changed. And how does it work? It's going to have a default value. For example, here we can consider a different value for the antenna mask here, and the traffic has been considered very low during the midnight, that it should be considered, let's say for example, as just usual MIMO 44R, and at the middle it would be a half antenna mask, so it should be 32T32R. The highest has been considered for the time, for example, between 3 to 5 p.m. And the others could be considered for the midnight. For example, we can consider 16T16 R for this time period, but it changes as a factor and as a function of the loads. And this our apps works in a way that these are the default value, and our base station is going to, let's say, change the massive MIMO order based on the time. But if something unprecedented happens and cell loads, let's say traffic loads, is going to be high, so if even we are in the midnight, the antenna massive MIMO, the MIMO from 44R will be jumped to the higher order, then to fulfill the user equipment's quality of service. Now I'm going to, this is the charts, this is charts from the previous simulation. Now I'm going to stop it, and I'm going to run the test and show the values and how it's going to be changed. For the first stage, we consider that now we have, let's say, the highest traffic loads. First of all, I'm going to run the test. It's a VIAVI RIC Tester simulator that we are using. And now this is already in preparation. And here we have the 6040 64R antenna, and now we are going to use our our app. So let me, I'm going, okay, this is the or our app, and at the first stage that now it is started to run, it's going to fetch the data, and as you can see, now it's a time that, for example, we have considered that the full antenna mask should works. So nothing is going to be changed in the cell traffic load. But assume that there is a, let's say a traffic loads is going to be down and we are going to turn off half of the antenna. So 32T, 32R should be considered instead of the, for example, 64T, 64R. And now let's say it will automatically jump to change it, and for sake of that, let's say now the users are fixed. Now I'm going to implement it here. I should stop at the first stage and then implementing it. And here, as we can see and expect, the cell throughput, this is the S1 cell throughput, is going to be to jump down. These are the different cells. This is as you can see, S2, S1, and S3. Now assume that even the traffic load is going to be lower than this. So we need jump from 32T, 32R to 16T, 16R. So now I'm going to show you here. Assume that we have this one in or threshold values here, and for sake of that I change it manually to show you that what's going on. Now I'm going to run it, and now we expect that it should be jumped down from 32 to 16T, 16R, as we can expect it here. And as you can see, we're going to fetch the data, and now even we have the lower value of the traffic load. So it's better that we jump to 8T, 8R instead of the 16T, 16R. So now assume that now the traffic load is going to decrease in a threshold value that 8T, 8R is needed. So now we can see that even the cell throughput is jumping to the lower value. Assume that in the lowest order of the MIMO, that is 44R, now there is a few number of the users, and 44R can satisfy the quality of service that we required for user equipments. So, or our apps is going to turn down the other part of the let's say antenna elements, and now it's 44R. And after that, if an unprecedented event happens and suddenly it's going to jump out to 64, 60 T, 64R, let's say antenna elements activated, and as we can see here, the impact of our apps that has been designed. And in terms of the energy efficiency, first of all, I should mention some important points. As you can see here, during, let's say, here consider a 30% of the time, the cell was on 60/40, 64R in the highest mode of the energy consumption. And after that, we are going to calculate that how much energy has been saved through our rApps that using the different, let's say, massive MIMO orders for fulfilling user equipments, communications, quality of service, and requirements. And in this part, these are the energy that as it was changing during the, let's say, when the antenna mask let's say changed. And let me show you in a, let's say, more illustrative way. And as you can see here, we can see the different order of the massive MIMO changing through our apps and changing in the cell throughput. And here we can see let's say the throughput of different pedestrians that we have 30 here, 10 for each cell, and we control S1, let's say, massive MIMO orders through our apps and our algorithm that has been designed already. And as you can see, most of the time the system was near the saturation. And these are the PRB usage and other fact that can be seen here and will be described in more videos. And thank you for your attention, and thank you VIAVI RIC from the VIAVI company that really support us on this works. This is for the REACH project of University of York, and I am Wahid Kuhdaraq, research fellow at University of York, and I'm leading the massive MIMO project on the REACH project, and my let's say responsibility is to design X and R apps for controlling a massive MIMO and beamformings variables through X and R apps as a function of the changing different KPMs or KPIs in the radio access network. And I hope that you enjoy these demos and tutorial. Thank you.